Hi there, and welcome to another episode on the It's All Good Mining and Repair channel. I'm Brian, and today we're going to follow up with the hashboard that I started naming the hashboard from hell. Um, on part 7 of the video, uh, I I was still troubleshooting it, but really did not have a hashboard that went back into the um, miner. So I want to show you now what's been going on with that miner because I did replace a number of chips, including chip number 1. So let's dive into what that looks like. What's going on? Let me flip over to the other computer and I'll show you what's happening. Here we go. You'll notice that the miner has been running for 15 hours, 37 minutes. Yeehaw. I am running the Vanish firmware because for me, it gives me the best diagnostic option. I just get it from vanish.net. If you'll look, so this is the one chip I've got, or one board I've got running. This is that board. Notice it only runs at 480 megahertz. It's hashing about 19 to 20. And the problem is the temperature on that last chip. So, and you can see here, it's got an X, which means the chip is dead. Let me flip over now and we'll see what's going on with all the individual chips. Okay, so here we go. Looking at the mining profile configuration, this is really helpful. It gives me a lot of useful information. So what I'm going to do today, you'll notice chip 55 is 0, right? There's nothing running on it at all. Likewise, chip 59 is really weak, as well as chip 61. I've been watching this. Chip 38 is also problematic. Chip 21 is problematic. Let's see. So 55, 59, 53 is problematic, sometimes more so than others. 38, 61 we talked about, and 21. I'm going to ignore 19 because I've just been watching it. It stays above 200. So I'm going to leave 19 and 39 alone. As well as right now I'm going to leave 37 alone because it seems to behave most of the time. Since I have this now, I'm going to take the board back out of the miner and we're going to take those chips off. We'll replace those chips because it's only 6 chips. Assuming that the chips cost me about $2 a piece, that's $12 roughly in parts to get this board running tip-top shape. Let me go pull the board and we'll see where things are. All right, so here we go. This is the board on the bench. And it's working, right? So it's all healthy and good. I just took it out. And what I'm going to do is I'm going to go ahead and disassemble it. I'm going to disassemble the board. And I'll show you what I'll do after that. Okay, looking at the pattern, it looks like pretty good heat sink or pretty good dissipation pattern on the grease. Everything looks good there. That's 55, so it doesn't look like we had any kind of problem with 55 not getting enough heat grease. So definitely it's a chip issue. Let me show you what I'm going to do now. If I had just one or two chips, I would just clean that chip off with a Q-tip and pull it. But since we're going to pull 5 chips or 6 chips, I'm going to go ahead and put it in an alcohol bath. Ooh, and look, we get to fix a nut. One of these days, I'm going to get good at putting these nuts on so they stay, but we'll come back to that. All right, so what do? All right, so you can see I've got a just a 9 by 13 glass dish. Pyrex, I think is what they call them. May not actually be Pyrex brand, but it's just full of alcohol. So I'm just going to clean. So I quit using my ultrasonic cleaner just because it took too much time. It took an hour to heat up and all that. If I've got a lot of boards on I need to do cleaning on, that's a great start. But if I just need to do a repair like this, this is what I do. I clean it up with the isopropyl alcohol, 99%, and then I take it out and I put it on the cooler for just a second, and you know it's evaporating because it gets really cold. So while I'm waiting for it to get cold, let me grab my sheet of paper. I just did a screenshot, right? So did a screenshot of it, and it's got what I need to do. So let's go to the overhead. Ooh, let's turn things around. I don't want to work backwards. 55 is right there. So even, here's the kicker, even after scrubbing, I see paste. So I didn't do a good job of scrubbing. But it's okay because I can kind of do a little bit of a touch-up clean. There we go, just like that. All right. So let's see. Let's mark them, right? Keep my list up here. I wrote them down, 55. So anything that like these are, if I had it in red, you'd see, but 53, 55, and 59 are just bad. They're red. So I'm going to mark those chips as the big X. So let's go see here. This is 10, 20, 30, 40, 50, right? 51, 52, 53, 54, 55. So 55, right? 56, 57, 58, 59. Okay. 60, 61. I'm putting a question mark because I think that's just a weak chip. It could be a bad solder job. These I feel pretty confident that they're just bad. We'll check. We will test these before I pull them. We'll test these with ohm meter Okay, so that's this one, this one, this one, this one. Okay, 38 and 21. Well, let's go find 21. That's the easiest one. Again, this is chip 1, 10, 20, 21. I feel like I've replaced this chip a couple of times. The kicker is, I think the chips I've replaced this with are chips that are not so good. I've been refining my chip testing process. I'm now down to 150 ohms. Anything over 150, I'm really not interested in keeping. At least for chips to replace. Now, I'll leave something on the board if it's usually if it's over, as long as it's under 200. Okay, so this is 21. So that's 31. That's 40. So we'll count backwards. 40, 39, 38. Okay, those are our 6 chips that we need to get rid of. The ones that are in X, I'm just going to throw those straight into the trash. They will not stick around. And let's go ahead, put red mark there, red mark there, red mark, red mark, red mark, and red mark. Okay. So I'm just going to strip all the chips off, and I'll do it my normal way. So let's go to the bench mode, turn the fan off. All right, I got this right there. Cool, cool, cool. All right, let me set my temperature and airflow 425. I've moved my airspeed up a little bit to 80 out of 120. Just a preference thing for me. Yes, I know there's a green background. I bought one of these chroma key backgrounds because I want to like chroma key my just my silhouette or my me, and I don't know. I'm having trouble setting it up. I think it's the lighting, because if you notice, see how it's shadowed there and it's shadowy there. I think I need to light the backdrop. So probably that's what's wrong. All right, but in the meantime. Okay, moving to the next one. That one went to the trash. Okay, I just saw something of interest here. So this pin right here doesn't have much solder on it. It could be that is VSS. So that's really just a ground pin. So the fact that that's not, no, wait a minute, hold on, is that right? Yeah. $16, $17. Sorry about that. There you go. It could be that's why that's chip 55, right? So that could be why it's misbehaving. Now these two pins right here go to the temperature sensor, right? They hook around, they go to here. If I was to measure at these two test points here on the other side of the board, I would find that they go to the temperature sensor. The plus minus signal out of the temperature sensor. So I don't think that one is the problem, but I'm not going to. I'll go ahead and toss a chip rather than fix it all up, put it back in, and find out it's still a bad chip. Now that is interesting. Look at that. We're going to have to do a solder repair on this one. Solder mask repair. Okay, this is chip 5 of 6, so we're taking off. And here is chip 6 of 6. There we go. 6 chips taken off. Now, while I was taking stuff off the board, or chips off the board, I had a failure there. I had a heatsink failure. It was adjacent to 55. It wasn't 55, but it was adjacent to 55. So let's just go ahead and fix that real quick. It's easy to do. Okay. First thing to do, clean it up. Don't want it dirty and nasty and corroded. If you look, let me put this on the microscope real quick. So as you can see, this one has had its looks like it's been taken off before. Turn me off. There we go. It looks like it's been taken off before. Because it's fully coated, there's no copper showing really. Usually the ones from the factory have a little bit of copper showing. But while I'm at it, let's get it nice and clean. Same thing with this guy. I'm just going to put that under the microscope so you can see it too. All right, so I like to have a little bit of solder on there, a little bit more than it's on there right now, which is not much. And I'll just use regular leaded solder. I'm not going to waste time putting on unleaded solder, so I put a little flux on there. Just going to load the tip with solder. Okay, so if you look, see it's got solder, right? Let me just put that on there. I could sit there and I think I got it pretty good. I need the light, so sorry about that. Okay. Whew. What did I do? I don't know. Okay. Got the light so I can see what I'm doing here, and you'll be able to see it as I... Okay, so I just come in from the top. Saw how it already moved there. But it's not quite right. When it heats up, it'll sit flat, just about like that. You notice it's not quite squared up. Okay, it's still rocky. There we go. Okay, keep in mind there's an actual chip on the other side of that, so you don't want to heat it forever. Next part, we'll clean up the chip. We'll clean up the pads, right? That's the next piece. So let's get into that next. All right. So we've got to we need to clean up these 6 pad sites, right, for new chips. But this one, actually, let me show you something on this one. So this is the one. Let's pull the microscope in. So before I even get started, what I see, I think I saw this originally and I just ignored it, right? Look at that right there. So we have a bridge happening, and that is why that chip or that spot wasn't really making a good contact. We potentially, the solder's, instead of the solder sticking right here, solder's just flowing right in here onto the pad, and it's not getting to the chip. So I got my grinder, and I'm going to do this hopefully without shaking the screen too much. Okay, what I want to do, just get the solder off the copper. Why? Because solder mask does not stick to solder. Real quick here, so just solder mask. Let's go overhead cam. I got this off of Amazon. UV curable solder mask. It seems to work. I haven't had any problems with it. Don't need much. All right, so just going to stick my needle inside the, rub it around, and then I'm just going to try to bring that down here and just touch it, right? Okay, I got a glob on there. That's literally, that was just the tip of the needle, right? So trying to take some of the solder mask off. I'll clean the rest of it off with a grinder after the fact, but I want to set it first. Just making sure that the solder mask is not too high, right? Because if it's too high, then it's going to cause a bridge and the chip won't seat properly. Okay, grab my UV light. I found out that I can plug my UV light into the USB port of my power supply, and it works real nice. Let that sit for 10 seconds or so as it's supposed to be, but I like to just let it sit there, so no hurry. And that is, you see, that's a UV. Woo. Okay. The nice thing about using UV solder mask, you can't overdo it. Okay. You can certainly underdo it, but you can definitely not overdo it. Oh, good, 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 good. Okay. So now we can touch it. It is nice and hard. All right. Just taking my razor blade, my X-Acto knife, and just scraping. Right, I'm not pressing. Letting the weight of the knife. I could have done this much nicer, but that's fine. That was not the point of my repair here. Okay. I do want to make sure that this dam is kind of straight. Now for this next piece, I'm going to just use my grinding tip. Okay. Very good. That takes care of that. Put some flux on there. Now, because I have previously cleaned this pad and put low temperature or leaded solder on there, I don't need to go back and what's going on? There we go. Okay. I don't need to go back and desolder the pad, right? Because there's no leaded solder on there or unleaded solder, so it's okay. And this is basically this 183 degrees solder on there, so I can just add more, freshen it up a bit. So I've got my soldering iron. Set to 180 or 382. Very good. Okay, that's good. Since I'm doing a bunch of chips all at once, we'll just keep going. Okay, this one needs a little bit of a cleanup. Okay, if I have to pull this chip off one more time, I'll probably end up doing a repair on that solder mask, just like I did on the last chip, but not today. Okay, next one. Most of these, okay, so down here on 17 or 17 and 18, 14 through 16, definitely need some help there. So let me fix my camera. There we go. Okay. Same thing, just going to put a little alcohol on there. Okay, this is chip 61 that we're cleaning up here now. All right, here we go. This one we're going to clean up. again, even though it looks, this is just dirty from the flux that I used. So this is chip 21. This one, actually, I can't say 100% that I've replaced this chip. The reason why I wonder about that is because of the way that looks. We'll go ahead and freshen it up though. Everything's good and shiny. I want to clean my tip off. And then I'm just going to touch the top, or just touch the pad there. Kind of smear it around. Just want to make sure that there's any oxidation. Looks good. Okay, good. Okay, I'm not cleaning these off because I am going to put chips on. But because I'm putting chips on, there's no reason to clean the flux off. In fact, that's just a waste of effort. Let me get set up and we'll start putting chips on. We're going to start with chip 61. That's the one I've got under the microscope. It's right down here. If you're looking at the big, can't really see it in my overhead because my camera is focused more on my work area. All right, so I've got my chips all ready to go. I got flux handy. Let's mount the chip, shall we? I plan to actually do one at a time and cool them off a good bit before I move on to the next one, because I don't want to get the board overheated. Ooh, that is too much of a zoom. I want it to come back out because I need to actually be able to work. Okay. I'm using what was the AG chip? I got some AH chips in there, but this looks like it's an AG chip. It's all good. Yeah, I think I probably should have not put that extra flux on there because it's making it a little too easy to move around. Okay, I could definitely move it over to the right of the screen more. Whew. There we go. Okay. And we don't really have anything to pry against. It's kind of easy to over push. Okay. Chips on a little bit crooked. There we go. Okay, looks like we got nice little bubbles everywhere. Water bubbles. Good, good, good. Turn the fans on. Take the heat out of the board. Okay, real quick, even while it's warm, you can still do this. I'm gonna put the continuity tester on there. I just want to make sure. Good, good, good. All right. Okay. That on the big fan for a second. Okay, I've moved on to chip number 59. Is that on my list? I thought it was 58. 59, yeah, 59 right there. So we've done 61. Done. Now we're doing 59. Cool. All right. Looks like we got plenty of solder there. So, or I'm sorry, flux. So turn the fan off because you will just fight the hot air will fight the fan, and you'll just put more heat into the system than you need. While it's heating up, let me grab a chip. Okay, making sure that pin 1 and 32, yeah, they're good. Pin 16 and 17 look good. Okay. Same thing as before, turn the fan on. And cool it off. Okay, so now I've moved, the board's cooled off, and so I've moved on over to, oh, look at that. Okay, yeah. I've moved on over to, this would be chip 53. So, same thing. The heat to it, start getting it to flow a bit. So one of my tweezers is still touching the board, just to help. This may have been a chip that I tinned by hand. That's what it looks like. Okay, so after it cooled off, I was looking at it, and I don't really like how, yeah. I think I just need to reflow it again, so that's what I'm going to do. Put a microscope cam for this one so you can see. I tested the 1.8 and the 0.8 rails, and they were not successfully going through. So before I declare the bad chip, on that regard, I will just reflow the chip. Okay, so that's a problem. We're not getting enough solder for whatever reason. My guess is I must have done this one by hand. I quit doing these by hand. Must have tinned this chip by hand. No worries about the solder I just left on the top. All right. Okay, this is turning into a disaster. Can I save it? I don't know. We'll find out. There's a ball. Okay. Tell you what, let's just go ahead and scrap that one. I'm not happy with what's going on there. Oof. So let's clean it all up. Oh, look at that. Okay, this is that one that I said was borderline. Okay. I literally touch the positive pad here, get solder to put on the side pads. Okay, you can see the positive pad there is, I think that's the anode pad, is all nice and melty. There we go, top of the chip got some heat on it, so good. And we can drop it. And this one should do much better for me. Ugh. Okay, that's from the positive anode pad there, so that's okay. There we go. Okay, we'll clean that one up with the soldering iron after the fact. Okay, it's good. All right, back. We're going to work on chip 55. Now, this is the one that we did to repair. Let me zoom in. Oh, good. If you look into the microscope, this is the one that had the repair done there on pin 19. So we did the solder mask repair. A little bit blurry. There you go. It's all ready to go. So back into bench mode. Let's heat it up. Let's go. Give it a bit of tap, just make sure all the contacts are nice and happy. It looks like they are. Okay, hit the fans. All right, so I've turned the board around after letting the board cool, and now we're on 21, 10, 2021. So let's get 21 replaced. We got 2 left, 21 and 38. Now I do have to pay attention because the anode side of the chip now is towards the top of my working area, not the bottom like all the previous. So make sure when I'm picking up my chips, pay attention to where pin 1 is. Ta-da! Okay, good. Got nice little tiny solder balls on all of them. Okay, let's go over to the microscope. Yeah, nice pretty little balls. That's what I like. All right, let's go back to the bench and we'll put the fan on. You can also scrape the top of the chip, get some of that extra solder off. There we go. Okay, so now I'm on chip 38. I did reorient the board again, just because chip 38 is actually in the 1, 2, 3, 4, 5, 6, 7, 8th domain, 8 out of 13. So it's really past the halfway point. So put my block on this side, and then I put the this domain out there where I can get to it with the heating air gun, hot air gun. Okay. Just kind of pushing this flux out from underneath. Otherwise, it'll start popping. It's funny to me. Sometimes I'll do a chip and it'll just fall right into place. Other times, not so much. Sometimes it's a struggle. Sometimes it's easy. Let's put the... Go ahead and turn the power supply on. All right, let's just make sure we have chips. Yay, we got 65 chips. Cool. That's what we want. Right, so let's see. Go to tester miner. Here we go. I don't know. Is that better? Yeah, I think so. Or how about this one? Oh, no, I like Team Miner 2. Okay, so we've got 65 chips. Good, good, good. Oh, hold on a second. Let's stop it. And then let's go to temp. And let's run a temps test. Make sure we don't get anything squirrely there. Okay, all the numbers look good there. 49, 30, 48, 50, 51. Okay, good. Current is, because we're not running the power supply at 20 volts, we're not really getting up, the current's not really up over 5 amps yet. Cool, great, I like it. So next step, we need to put, let's see, what is it? We gotta put this one right here, and we gotta put this nut. Oh, we've lost the nuts in the same domain. So we got two nuts we need to put back on. So let's turn off the tester. Okay, so this one is going to be fun. I took a little bit of time extra because well, I grabbed the sleeve of the soldering iron when I was changing the tip and burned the crap out of my first finger and hey, that finger, this finger. So anyway, stupid things that happen, right? Hurts, but it'll go away after a while. You see this thing right here. I'm gonna put a picture of it in my when I edit this video. But this is a Zeftronics Airbath ZT1. So it spits hot air to the bottom of the board, and it basically it warms the board up from the bottom. So when I'm putting on, let's get the microscope. So I need to put a nut. This is what I've started doing recently, and this seems to really be helping. So I use my MG Chemicals flux. Put a little flux there, right? You can see the flux is already melting because the flux, the board's getting on its way up to 150 C. So at 150 C, none of the chips will float. The solder won't melt. But there's some other things I've done. I've changed out my tip on my hot air station. It's now an angled tip because I'm going to be soldering from the top. I've also changed out my soldering iron to the biggest wedge I've got. See, it's almost as big as a chip. It was when I touched that sleeve right there with my finger. Even though I'd already taken it off, I touched it with my finger while it was on my workbench. Okay, so how many different ways can I hold things? Let's go ahead now. Kind of adjust it. Start putting the air on. Okay. Just really want to split that difference between the two. Alright, I think going microscope only will be a better thing here. So split the distance. Now I come in with my soldering iron. Okay, I just get things starting to heat things up. Now my soldering iron, 415 or 412, somewhere in there. I just bump it into place. And I put some heat on that nut. Putting some pressure to really get the nut to make contact with the plane, the copper plane underneath. And things look nice and flowy. I pull my hot air back. I'll grab my tweezers since they're closest to me. And I'm going to use the tweezers to just slide off soldering iron. I found whenever I just picked up the soldering iron, sometimes the nut would stick to the soldering iron. Okay. Now I regret the fact that my fan is out of reach. The other thing I can do is I can switch my Zeftronics over to cool air. Give it a tug. Right? Clearly I'm picking it up and the nut's not falling off. So, okay. Let me move things around and we'll do the other one. This is between chips 26 and 35. All right, so this is chip 26, 35. All right. And the kicker with the Zeftronics is you need to let it warm the board up a little bit. So it's not like a hot air station. You don't put the heat on there and it's instant, right? It's since it's only going to 150°C, it's not putting as much heat on the board as fast as a hot air station. All right, I'm gonna go ahead this time and set the nut in place. Okay, there's the nut. I get the hot air station. I'm bringing the hot air in. I grab my soldering iron at 400 and it says 13 right now. Just want to get things nice and warm. You can see once I put the soldering iron on there, that heat goes through that nut real fast. There we go. You can see that glob of solder just touched up to the nut. Good, good, good. Okay, I'm keeping the soldering iron on there. Took the hot air away. Sliding on over. There we go. Okay. So I did one with tweezers. I did one with the multi-tool. All right, we're back. And I took the Zeftronics away and I put my keyboard, well, I guess I didn't quite. Let me put my keyboard back in place. I have to lower my keyboard stand just a little bit when I do this. Good. Nope. To lower it a little bit more, apparently. Okay, there we go. All right, so the board's back in place, and before that hurts. That annoys me. I got a little ice pack right here. Okay. Boo-hoo. At least, again, it's not as bad as my arm or my leg. Let's just test before I give it an alcohol bath. I want to test again because at this point I've done what I need to do, right? I just need to button this thing up and put the heatsink on. So let me go over to our tester mode. 65 chips. Look at that. That's good. Good, good, good. You know what? I'm curious. let's check something. CI, right? Because this is one of those troublesome things. Oh, CI still. We still lose our CI after 46. Because I lose it on so many boards, I really think it's in the tester. My ampere or my voltage and stuff reads right, so I just think it's a crappy thing in the tester. But again, I can't figure out a way to reach out to the team miner, you know, ant miner tester people. So, all right, no big deal. No sense in complaining about it. All right, let's check. All right, let's go do a temperature check. There we go. 51, 51, 52, 53. Cool, cool, cool. Very good. Okay. Let's go ahead now and I'll flip over to the overhead only. All right. So let's put the heatsink grease. Like I said, I just use HY 510, just some thermal grease. Not a big deal. A dab will do you. Okay. Now, one thing I failed to mention before I started this is make sure that the tops of your chips are smooth, right? If they're not, you need to clean them off. But since these are all smooth and the ones I put back on were freshly cleaned chips, I wasn't really worried about it. Also, make sure you don't have a bunch of flux on top of your chips. Otherwise, that can cause problems. Now, the other thing I did in between, I didn't think you really wanted to watch. I cleaned up the heatsink, right? So I scrubbed it off the same way I scrubbed off the board. All right, now we've got to remember the little side goes down here. Okay, gonna line this back up. Now, I didn't do it. I should have done it. It's that old saying, do as I say, not as I do. I got lucky because I put nuts back on, but I didn't check the alignment of said nuts until just now. If one of those nuts had been out of a line, that would have been a mess to put back on. So, okay. So now I'm just going to put the four corners in, like so. Just drop them in there. Oh. And then I just lightly just get the screw to start the thread into the nut. Okay. All I'm doing here is just making sure from a positional standpoint that we're good. Now I'm going to use the camera here to look and see. Doesn't look like anybody's really out of alignment. I'm just checking the alignment on a couple because just don't feel quite right. There we go. Okay. Okay. Yep. Good, good, good. Okay, everything's in. So now I'm just going to go through and just give it a couple of turns on each. I'm not trying to get them snug, trying to get them started. Okay, now just holding the tip of just the barrel of the screwdriver, I'm just going to go back through and just as snug as I can get it with twisting this. I'm not going to grab the big handle. I'm not going to use any kind of real torque. And I don't have a torque pattern other than just row by row. Okay, good, right? We're done. Yay. Hold on. Stop. There's a piece missing. Okay, so let's put this on here. And remember, this bar is actually, there's voltage on this bar. So when you're doing assembly on this, you want to make sure that that bar is not touching your heatsink. Whether you're using a upgraded heatsink, like the ones I use, or you're using the original factory heat sinks that are individual to the chips. If that gap right there goes away and you touch this rail to that heat sink, to that domain, you will have a short. It will not be good. Okay. Let's check out I'm going to flip over to tester mode. Yeah, here we go. I'm going to put my negative on, positive on. Okay, turn the fan on. Hit the start button. 65. Whew. Nothing more frustrating than hitting the tester after you put the whole board back together and nothing works. But that's not the case today. Okay, hit the temperature. All right, looky there. A little bit nice and good there. We've got all 4 temperature sensors are reading. So the next stage is to put it back in the miner, turn the miner on, and see how it does. So that's what I'm going to do, and I'll show you what happens once it's in the miner. Okay, so we are back at it, and it's installed in the miner, and look at this sad thing. Right there, we have chip 55 is still showing a problem, and the other issue is that I'm struggling with a temperature issue. I had to actually lower the frequency down from 480 to 400 to get this thing to stay running for a bit. That's a bit of an annoyance because I need this board to run at least 500 megahertz. So it's definitely not ready to go yet. But let's see how we did replacing chips, right? Let's see. We know replacing chip 55 didn't do any good. Okay. So that definitely looks better. If I grab my sheet, and I'm just going to pull the logs up while bring this up here. We'll just keep an eye on this because this guy right here, if we get into a temperature issue, it will shut down. All right, and we'll see it in the logs before we notice it in the web UI. Okay, so if I compare my previous, which I don't have a screenshot of anymore because I didn't save it. All right, so previously I had problems with chips 55, 59, 53, 38, 61, and 21. So let's go look and see. Okay, 55 is still a problem. So really the only chip we have an issue with at this point is 55. So I'm going to shut it down and pull it back apart and replace chip 55 again. Now this time I won't actually go through the full cleaning of the board and everything like that. So let me go ahead and tell it to shut down, and I'll be back when I have it open and get it apart. Board has been pulled out of the miner, and I took the heatsink off. Now you might notice there's still heatsink grease on everything. I didn't do an alcohol bath for a couple of reasons. One, I don't really want to get alcohol on my finger. And two, there's really no reason when you just have to work on one, you can localize your cleaning with Q-tips and alcohol, and if you really need to, a scrub a brush. But let me show you what I found. This right here, the 0 ohm resistor is missing. So that's what we're going to fix, because these are little bitty guys. All right. Let's see. I'll pull the reel out. I think I gave $10 for 1,000 of these little 0 ohm 0201 resistors. Oh, that's fun. It almost disappears, doesn't it? There you go. All right. Put my bag of 0 ohm resistors up. Don't try to like harvest these off of a board. My gosh, it's not worth it. 1,000 0 ohm resistors off of eBay for like less than $10. I think you can get, if you want to place an order off of Mauser, depending on where you are in the country, if you're in the US, I think it's like $15. Really, it's the shipping that causes you a headache with a single order like that. All right, I'm gonna turn my board, because what I want to do I want to come in here and I want to place this. And I'm just going to touch it. And I guess I need a little bit more solder. Okay. Right. So that was the only thing I could find that was wrong with it. Now I'm gonna. So now I got my meter, and I'm putting my meter in continuity mode because I just want to make sure that we've got both sides of this resistor. All right, let me grab my sharp pointy. Move the microscope around a bit. Cool. I want to make sure that the soldering job was good. And it was. So there you go. So that was that was the missing thing. Now what is that? 1, 2, 3, 4, 5, 6. That was a 6-pin. And the 6-pin, according to my sheet, that's the address number 2 pin. So since that wasn't set, it didn't really know what it was. So there we go. That should do it. I'll put it back together. I'll clean it up, and I'll put it back together, and I'll let you know what happens. All right, success. We have 65 asics all running. Temperatures are well within norm, and here's the good news. Notice that the temperature on chip 55 is not the highest temperature on the board anymore. It's actually chip 15 that's showing the highest. But the good news is chip 15 and 55 are on the same side of the board, right? So they're on the downwind side of the board, so they're going to naturally be warmer because they're farther away from the fan. It's now working like it's supposed to. When I check my logs, everything looks good there. Yeah, yay. Okay, and if I check the mining profile so I can see the frequencies, I notice that none of the chips we replaced are now red, including 55. In fact, 55 is reporting as being a very good, healthy chip. Looks like 41 and 19 are the kind of weak chips, but they're not really weak. They're just a little weak. I'm not going to pull the board back out and tear it all down just to replace those. I will keep a note on those for that board. And if I do take the board out, I might replace those 2 chips so I can have a all optimum board. Now this board is running at 515. So that is not, if I go here and look at my presets, 515 megahertz is going to be somewhere between 65 terahash and 68 terahash if I had all 3 boards in the miner, which currently I only have 1 board in the miner. So it's not quite running at S17 plus levels, but the reason I'm running it at 515 and not any higher is because if I try to run it higher during the startup phase, it overheats and shuts down because of airflow where I have this test miner set. So good enough for now. We've got a working miner that's I'm going to consider fully repaired. I'll leave it running and let it hash for a while and keep working on other boards. If anything else comes up with this board, I'll add it to this playlist. Thanks for watching. Hope you learned something. Have a great day,